For centuries, the solar system was viewed as a standard blueprint for planetary systems in the universe, with our Sun at the center of a circular track, and a planet orbiting within each lane. But over the past 20 years, more powerful telescopes have revealed a host of exotic systems with completely unexpected configurations. Now, an even weirder planetary system may render the puzzle more challenging. Using NASA's Spitzer Space Telescope, scientists have discovered an oddball planet with a highly eccentric orbit that moves like a comet, the second to be spotted this month. The planet, called HD 80606b, is about the size of Jupiter, though 4 times as massive, and resides in a system 190 light-years from Earth, in the constellation Ursa Major. It is similar to hot Jupiters, massive roaster planets that circle scorchingly close to their stars. Scientists have puzzled over how these gas giants, which supposedly form far from their stars, end up on such blistering orbits. What makes HD 80606b stand out is its highly eccentric orbit. Instead of maintaining a circular path, HD 80606b spends about 100 days of its year traveling an oblong route away from and then returning toward its star, much like the trajectory of a comet. Then, in a matter of just 20 hours, it sweeps around the star, very nearly touching it, before swinging away again. At its closest approach, the planet receives an enormous amount of energy from its star, over 1,000 times the energy the Earth receives from the Sun each day. It was spotted by astronomers MIT, the Space Telescope Science Institute, the University of California at Santa Cruz. If the Earth were to be moved that close to our Sun, it wouldn't take long for it to lose its atmosphere and turn its surface to magma, said Julian DeWitt, a postdoc in MIT's Department of Earth, Atmospheric and Planetary Sciences. In a paper, published in Astrophysical Journal Letters, DeWitt and his colleagues report on observations of HD 80606b over 85 hours, during its closest approach to its star. The researchers studied how the planet's temperature changes as it approaches, sweeps by, and moves away from its star. They determined that while the star-facing side of the planet boils up to an extreme 1,400 kelvins, roughly 2,000 degrees Fahrenheit, during the swing-by, these roasting temperatures are short-lived. Surprisingly, they found that the planet cools in fewer than 10 hours as it orbits away, reaching temperatures so cold that it becomes invisible to Spitzer for the rest of its orbit. This happens every 111 days, DeWitt added. The good thing is, the planet goes so far away that the process is a complete reset. It's the same story over and over again. It's thought that hot Jupiters start out in circular orbit similar to that of our own Jupiter, far away from their stars. At some point, something large and massive like a nearby star pushes them into eccentric orbits. These planets are then squeezed by their star's gravity every time they whip close by. During every close encounter, a fraction of the gravitational energy used to squeeze the planets is dissipated as heat, slowly reducing the eccentricity of the planet's orbits, which eventually end up tight and circular, a process known as circularization. HD 80606b, therefore, is thought to be mid-migration, slowing moving from an elliptical to a circular track. How long the phase lasts depends on how squishy or pliable the planet is, given its interior properties. The more pliable a planet, the better it is at releasing mechanical energy as heat. Based on the squishiness of the giants in our solar system, the phase is expected to occur over a relatively short period of hundreds of millions of years. And scientists believe this mechanism might explain how hot Jupiters eventually evolved their close-in orbits. However, the new Spitzer observations suggest HD 80606b is not as squishy as expected. Therefore, HD 80606b is not migrating as fast as previously thought and may maintain its highly eccentric orbit for another 10 billion years or more. If this is the case, DeWitt said scientists may have to rethink theories on how hot Jupiters are formed, as it implies that the underlying migration mechanism may not be as efficient as once believed. The researchers also calculated the planet's rotation rate, the first time this has ever been obtained. HD 80606b's rotation rate, essentially the length of its day, is estimated to be 90 hours, which is twice as long as predicted for this planet. The system is undoubtedly very unique as it seems to challenge in many ways our understanding of planet-star interactions and planet formation, Dewey concluded. Hopefully, future studies of similar systems will help us evaluate how special the system is and how far off our initial theories were.